This is a video for the pre-calculus quarter 4 progress check review. The first 2 pages are your formula sheets, and then number 1, A dot product B. So we're gonna multiply the X coordinates, add, and multiply the Y coordinates. So that is 12 plus negative 15, and we get negative 3. Now for B, we're gonna first subtract the vectors before we do the dot product. So A minus B is 2 minus 6, negative 3 minus 5, and then we're gonna dot product that with B. So then negative 4 times 6 plus negative 8 times 5, and then add those quantities together. Now we're gonna add the vectors and then dot product A. So 2 plus 6, negative 3 plus 5, dot product A. So 8 times 2 plus 2 times negative 3 for 10. And you can use your calculator for the whole test. So for the arithmetic, if you wanted to use your calculator, you could. All right, B, we've got Jake throwing a dart. The parametric equations, if you look at your formula sheet, are down here on the bottom of the first page. So we've got X is initial velocity, cosine of the angle t, Y is negative 16t squared plus 58 sine of the angle t plus an initial height of 4.5. If the target is 100 feet away, how high does the dart have to be off the ground to hit it? Well, let's graph it. I'm going to first change my calculator to degree mode and parametric. Then I'm going to go to y equals. Make sure you are typing everything in correctly. And then I'm gonna go to my window. Tmit is 0, Tmax, let's do about 10 seconds. Your T-step should always be 0.1. That's better. The dart can't go behind us. We're gonna look at least 100 feet away. So let's look to 150 for the X max. And how high do I think the dart will go? Let's just say 50. And there is the path of the dart. I'm gonna trace to find a time close to 100 feet away. So I'm looking at the X for when that gets close to 100. All right, so that's near 2.3 for T. I'm gonna do second window. Table start is 2.3, and I want the table to change by 0.01. And I'm looking for the closest value to 100. So it's between these 2 times. So let's see, the height, so how high does the target have to be off the ground? Let's say 8 feet, so between those. So the Y value would have to be 8 feet. Okay, number 3, same kind of problem. Initial velocity, cosine the angle t, negative 16t squared, and it's hit from 4 feet off the ground. What is the maximum height and when does it occur? So we got to replace our equations. I'm gonna change my window because this is a baseball and the initial velocity is way higher than the prior problem. So let's make our X max, let's go 300, and the Y max, let's go 200. And if those don't work, I'm just gonna increase or decrease them. All right, so my Y max is too high, my X max is not far enough. I'll make that 500 and 100. It's a little better, and I only need the maximum, so I don't really care where the ball hits the ground, so I'm not gonna mess with the window anymore. I'm gonna hit trace and go towards the vertex, and I'm looking at the Y value. So it looks like 50.7 is closest, and that is at 1.7. So I'm gonna go second window, 1.7 for table start. And then I'm gonna look over here and look for the highest Y, which is right there. So the maximum happens at 1.71 seconds. The height of it is 50.791 feet. Okay, another one. Hoop shoots her arrow. So another parametric. Initial velocity. Cosine of the angle t, negative 16t squared, sine of the angle, plus an initial height. Gotta change my equation. When does the arrow reach the ground? All right, well, let's see if we can see. No, not far enough out over here. If I hit on, it stops it from graphing. So then let's look to 1,000 feet because 500 was not enough. Oh, good, 1,000 was. So I'm gonna hit trace, hold down the right arrow till we get over near that x-intercept. All right, so that's near 3.6 seconds. So second window, 3.6, second table, and I'm looking for the Y value closest to 0. That one, negative 0.2 is. So it reaches the ground at 3.58 seconds at a distance of 872.061 feet. If a person is standing 840 feet away, oh, that would be another clue to your window that you know X has to be more than 840 with an apple on their head. All right, so let's look where X is 840. So that's 850. So sometime between 3.4 to 0.5. So let's start 3.4. 840. There we go, right here. The apple is 6.75 feet from the ground. Will the arrow hit it? No. The arrow is 7.08 feet high when 840 feet away. So it just misses. Okay. Now we've got parametrics here. And X is 3 plus sine of t. Y is 2 plus cosine of t. Oh, I don't want to graph it. I just want my table. Uh-oh, wait a minute. Second window, start at 0. Go up by 1, so I'm going to change that to an integer. Okay. I'm going to switch to radian mode because it doesn't say, and these values are better. So we've got 0, which is at 3.3, 1, 3.8, 2.5, 3.9, 1.5. So I'm just filling in the chart from my calculator. It doesn't say the decimals. I really should be consistent with my place values, but I'm not. Sorry. Okay, so now without the t, I can plot these points. Okay, so we're gonna go 3, 3, and then the next point is 3.8, 2.5. It goes like that, and then 3.9, 1.5. And then 3.1, 1, and then 2, 2, more than 1, 2, 2 and a quarter, 2.7, almost 3. Oh, it makes a circle. Okay. Oh, now we're given the circle. So let's see. Based on this, over 3 and up 2, it looks like the center is at 3, 2. Well, look. 3, 2. So now when we have this equation, if the center's at -4, 1, x is going to be -4 plus, and y is going to be 1 plus. They're telling me x is the cosine, and c is the same here. So what's constant in a circle is the radius. So this radius is 1, so I'm going to do 1 cosine t, 1 sine t. All right, we're gonna do that again. Here's my circle, 2, -3 with the center. So A is the 2. The radius is 1 again. And then the y coordinate of the center. And those are our answers for 7. Okay, now on to matrices. A plus B. The dimensions are equal, so I can add 3 plus -5, -1 plus 4, and be done. For B, the dimensions of A are 1 by 2, and B is also 1 by 2. So that is not defined because the inner dimensions do not match, so we cannot multiply the matrices. The same thing is going to happen again for B times A. I can subtract them. So -5 minus 3, 4 minus -1. The bars of C mean determinant. So the determinant of a 2 by 2 is going to be, where's C? Here we go. 2 times -1, let me write it out, minus 4 times -6. That is 22. The calculator will also calculate a determinant for you. The only problem is if there is a variable, you can't then rely on the calculator. So it's nice to be able to do that algebraically. I wonder, is that on your formula sheet? Let's check. It is not. There's nothing about matrices on the formula sheet. Okay. C minus D. The dimensions match, so we can subtract them. 2 minus 9, -6 minus -5 is like plus. 4 minus 2, and -1 minus 4. All right, D times C. Order matters for multiplication. So our answer for H is going to be something different. Okay, so when we multiply matrices, it's row by column. That will get me the value in the first row, first column. So 9 times 2 is 18, plus negative times 4, negative 20. So 18 minus 20 is negative 8. No, it's not. It's negative 2. Then, get a different color. Row by column. It's going to get me the entry in the first row, second column. So 9 times negative 6, let me say, this way I won't have to hold it in my head. 9 times negative 6 plus negative 5 times negative 1 is negative 49. Then I do the second row, first column. 2 times 2 plus 4 times 4 is 20. That was doing this row, this column. And then lastly, 2 times negative 6 plus 4 times negative 1 is negative 16. Now for H, D, or C times D, so 2, negative 6, 4, negative 1, 9, negative 5, 2, 4. We're gonna go row by column. Can you see that? All right. 2 times 9 plus negative 6 times 2 is 6. And then 2 times negative 5 plus negative 6 times 4, negative 34. Then for the second row, 4 times 9 plus negative 1 times 2. And then 4 times negative 5 plus negative 1 times 4. So you can see that order matters for multiplication. These are not the same result matrix. A times F. So A is a 1 by 2 and F is a 2 by 3. So that'll work. We're going to get a 1 by 3 answer. Okay. Row by column. So 9 plus negative 1 is 8. 0 plus negative 2, and negative 6 plus 0. Now for J, E minus F will not work. The dimensions are not exactly the same, so that one does not exist, or is not defined. Let's see, E times F, so E is a 3 by 2, F is a 2 by 3, so that will work. E. So we've got row by column. So that's negative 6 plus 1, 0 plus 2, 4 plus 0. Then we're going to do 0 plus 3, 0 plus 6, 0 plus 0, my favorite, 15 minus 2, 0 plus negative 4, and negative 10 plus 0. All right, I'm going to fit L down here. A minus 2b. So I'm going to take the entries in b and multiply by 2. And then subtract. So 3 minus negative 10, negative 1 minus 8 for the answer to L. All right, does DC equal CD? No. We already said that. Order matters in multiplication. Oh, that's a major typo. Without finding it, will C have an inverse? Well, we found the determinant of C, and that is not 0, so yes, C will have an inverse. Determinant does not equal 0. Let's see what D is. The determinant of D is 9 times 4 minus 2 times negative 5. That's not going to be 0. So yes, D will have an inverse. Okay, a few more matrix problems. What is the identity matrix for a 2 by 2? That is 1, 0, 0, 1. What is the result when a matrix and its inverse are multiplied together? So like if you have A inverse times A, you're gonna get the identity matrix. If it's a 2 by 2, that's what it would be. If it's a 3 by 3, that's what we would get. You get the identity matrix because the inverse times the original, it's like they cancel each other out. So you get the matrix that would be like the value of 1. All right, X and Y. So row, I'll choose the first column. Gives me the value in the first row, first column. So that's 1 times 7 plus 9 times Y plus 3 times 11 for 58. So if we simplify that, that's 7 plus 33. It's 40. Subtract the 40. 9y is 18, so y is 2. All right, let's try X. That's row by, I don't know, let's use the second column. So second row, second column gets me the value in the second row, second column. So X times 8 plus 5 times 10 plus 6 times 12. No, that's not right. Sorry. 72 is 154. So we're going to add 50 and 72 plus subtract the 122. So 8x is 32, so x is 4. Determine the value so that the matrix does not have an inverse. So that would mean the determinant equals 0. So 3x minus 6 times 2 needs to equal 0. Add the 12 to the right and divide by 3. All right, a few problems left. So for number 13, there are 13 members of the club, and we have to elect president, vice president, and secretary. So for the different ways order matters, so that's a permutation. There's 13 total people, and we're picking 3. All right, so I'm gonna type the 13, go to math, over to PRB, so number 2 is permutation. And then 3, so that is 1,716 ways. If it said there was a committee of 3 people, that would be a combination because order wouldn't matter which way you selected the 3 people for the committee. All right, how many different license plates are gonna have 2 digits, 2 numbers, 2 letters, and then 3 more digits? No, none are repeated. So 0 through 9 is 10 numbers to start, then 9, then 8, then 7, then 6 choices. And there's 26 letters, and then when you take one out, that leaves 25 letters. So I have to multiply all of these values together. And I'm sorry the video is wobbly. I switched tables, but there's only a few problems left, so hang in there with me. And we get 196,560,000. So that is 19,656,000 different license plates. A new car customer has to choose 3 models, 4 exterior colors, 3 interior colors, and any up to 6 accessories. So that's 3 times 4 times 3 times 6 for 216. Okay, expand. You do not need to simplify each term. To get the coefficients, we're going to use combination. So it's going to be 10C0, 2x to the 10th, 7 to the 0, plus 10C1, 2x to the 9th, 7 to the 1st. And we're going to decrease this exponent and increase that exponent. This is a long one. Almost done.
You haven't started the video yet, have you?
Yes, I'm doing a video right now. And last term. Okay, so that's all the values written out. Standard form means that we have to start with the x to the 10th. So I went in order with the x down to 0. What I should also do is figure out these coefficients, the 10C0, 10C1, 10C2. So I hit the 10 first. Oh, sorry. Go to math. Over to probability, and number 3 is C, and 0. Then if I hit second enter, I can go back and change all of those second values until I get all the way down to the last one. All right, now for 17, all right, it's only 5, so we're gonna do 5C0, a to the 5th, 3b to the 0. These two exponents should always add up to the 5, plus 5C1, a to the 4th, 3b to the 1st. 5C2, a to the 3rd, 3b squared. 5C3, a to the 4th, 3b, nope, wrong way, 2 and 3. So 3 minus 1 is 2, 2 plus 1 is 3, plus 5C4, a to the 1st, 3b to the 4th, 5C5, a to the 0, 3b to the 5th. All right, and since this was a more reasonable amount of terms, I'm actually going to calculate. Oops. 5, math, probability, NCR 0. So that is 1 a to the 5th plus 5 a to the 4th times 3b to the 1st. And since we don't have to simplify each term, I don't have to multiply the 5 and the 3, which is nice. A to the 3rd, 3b squared. 10 again. So now it's going to repeat. I'm going to go back to 5. A to the 1st, 3b to the 4th, plus 1 times 3b to the 5th. I leave out the a to the 0 because that's just 1. Okay, last one. 4C0, 4C1, 4C2, 4C3, and 4C4. Now I'm going to add those up. Then it's going to be 4x to the 4th, 4x to the 3rd, 4x squared, 4x to the 1st, 4x to the 0, negative y to the 0, negative y to the 1st, negative y squared, negative y to the third, negative y to the fourth. So first one's always 1, 4x to the fourth, plus 4 times 4x to the third times negative y, plus 6, 4x squared negative y squared, plus, this is going to be 4 and then 1 for the coefficients. And you are done the progress check review.